Welcome to today's Explainer. We're diving straight into a brand new 2026 systematic review and meta-analysis that takes a hard look at an absolute staple of the fitness world, vitamin C and post-workout recovery. We're going to strip away the marketing, look strictly at the hard data, and see what the science actually has to say about this daily habit. It's a question literally anyone who's ever pushed hard in a gym has asked. You crush a workout, you wake up sore, and you immediately reach for a supplement. But is popping that post-gym vitamin C pill an actual biological necessity that speeds up recovery, or are we all just buying into a highly marketed placebo effect? Let's figure it out. Okay, here is our roadmap for today. We'll start with the post-workout vitamin C myth, go inside the meta-analysis, track the inflammation and stress, look at what the data revealed, discuss the problem with the evidence, and finally answer the big question, should you supplement? Section 1. The post-workout vitamin C myth. Let's tackle that widely accepted claim right out of the gate. To really understand the myth, we first have to understand the mechanism. Think of your body as a high-performance engine. When you do an intense workout, that engine generates a sort of metabolic exhaust or rust. We call this oxidative stress. It happens when reactive oxygen species completely overwhelm your natural antioxidant defenses. This causes lipid peroxidation, which is basically just damage to your cells that delays your recovery. So, enter vitamin C. It's a highly potent, water-soluble antioxidant. Biologically speaking, it seems like the absolute perfect sponge to wipe up all that post-workout oxidative rust and stop that inflammatory cascade right in its tracks. On paper, it sounds flawless. Section 2. Inside the meta-analysis. But does that perfect theory actually hold up in a rigorous clinical setting? Let's take a look. This flowchart brilliantly illustrates the massive scientific detective work the researchers had to do. They didn't just cherry-pick a couple of papers. They sifted through over 1,400 initial records just to find 12 eligible, double-blind, placebo-controlled trials that actually met their strict criteria. And what's really great here is the incredible diversity of the participants. These 12 trials tested literally everyone. We're talking heart failure patients, obese adults with type 2 diabetes, completely untrained individuals, all the way up to highly trained recreational runners. Having this broad pool of data is amazing because it helps us look for universal underlying patterns across completely different body types and fitness levels. Section 3, tracking inflammation and stress. How do you actually measure recovery in a lab? You can't just ask a guy how sore his legs feel, right? You need hard data. So, the researchers tracked 3 main biomarkers. Think of them as the main characters in our data story. First, CRP, a downstream inflammatory protein. Second, IL-6, an early-phase inflammatory cytokine that kicks off the whole cascade. And finally, MDA, our key marker of lipid peroxidation and oxidative stress. Section 4. What the data revealed. Okay, let's see what happened when the researchers actually pooled all this data together. The verdict was absolutely fascinating. If you look at these forest plots, you'll see the top chart for CRP dropped significantly in favor of the vitamin C group. But look at the bottom 2 charts for IL-6 and MDA. They stubbornly cross that center vertical line of no effect, meaning, statistically speaking, vitamin C did absolutely nothing for them. And the statistical reliability behind this is wild. See that I-squared value? It measures how much the studies disagreed with each other. For CRP and IL-6, it was 0%. That means the data was 100% consistent across every trial. But MDA, 80% heterogeneity. It was wildly chaotic, making the antioxidant effect on oxidative stress totally unpredictable from one study to the next. The authors sum it up perfectly right here. Vitamin C seems to have a minor downstream anti-inflammatory effect. It lowers CRP, but it absolutely does not alter the core early-phase inflammation of IL-6. And it doesn't reliably change your oxidative damage. It's a highly selective, very limited biological response. Section 5. The problem with the evidence. Now, before you go celebrating that tiny drop in CRP, we need to talk about a major plot twist. Look at this Cochrane risk of bias assessment. This sea of yellow and red circles is the researchers' way of flashing a giant warning sign. The foundation of these clinical trials is incredibly shaky. The vast majority of the studies they looked at presented some concerns or a straight-up high risk of bias, mostly because of selective reporting. So we have to contrast the mathematical win against the harsh clinical reality. Yes, on a spreadsheet, CRP showed a significant reduction. But clinically?
Using the grade framework, the certainty of this evidence is ranked as low to very low. Why? Because that statistically significant drop came from just 2 trials pulling a combined sample size of 52 people. That's it, just 52 participants total.
Add to that a whole mess of complicating factors. Many of these studies didn't even bother tracking the baseline vitamin C levels of the people they were testing. Doses were all over the map, from 500 up to a massive 4,000 milligrams a day, on completely different schedules. Plus, and this is huge, scavenging too much oxidative stress might actually prevent your muscles from adapting and growing stronger from your workout.
Section 6. Should you supplement? So, bringing all of this together, what does this mean for your gym routine?
We have to be impartial here and report this study's final conclusion. Based on this very limited, low-quality evidence, vitamin C supplementation just does not consistently or reliably modify post-exercise recovery markers. The data is simply too uncertain to make definitive claims about whether it's helping you or harming you. But there is one absolutely crucial takeaway here: the baseline factor. Taking a vitamin C supplement really only shows biological effectiveness if your baseline levels were inadequate to begin with. If your diet is already rich in vitamin C, flooding your system with more pills is basically just creating expensive urine. It's likely not doing a thing for your recovery.
Which leaves us with a pretty massive thought to ponder today. If the science behind one of the most basic, popular, universally accepted supplements is this totally inconclusive and shaky, it might be time to critically reevaluate absolutely everything else you've got packed in your gym bag. Thanks for joining me on this deep dive into the data. Keep questioning, keep learning, and I'll catch you next time.